Skill number 1-2, operational test of the aerial device. So we'll be operating it. So we're going to start off, park the apparatus in a suitable location so you spot your truck, properly engage PTO, and set chocks. So that's something we do in the cab. We spot the truck, press the floor brake, air brake, neutral, aerial master, aerial PTO, and high idle. All right. I want to impress upon you that the importance of that, because if we don't do it right, we can cause unnecessary problems for ourselves on scene, and now we start to spiral out of control because of a problem that we caused for ourselves. There's enough unknowns and enough variables on any fire scene. We need to definitely control the things that we can control. And I want to, it's the same thing as being in pump gear on an engine. You know how much we harped on you, how important it is. If you show up and you're intending to use that pump, you're gonna make sure you're in pump gear before you leave that cab. How many different ways did we give you to check that, make sure? Like 3 or 4 or 5 different ways to make sure you're in pump gear. Same goes with this. If you're intending to use this aerial device, make sure you have your aerial master, your aerial PTO, and everything is good to go. You're in high idle before you leave the cab. All right? So Blackstone, why don't you jump up here? We can fire this thing up. Right there, yep.
So we got the aerial master, the power.
Yeah, that typically, that's right. We want the aerial power flipped. Typically, I think that's a little mislabeled because I think that could get confusing, but it should be aerial master is what you'll see for that one, and then the one you're about to flip should say aerial PTO. All right.
But it's the same thing, basically.
Yeah. This is the same thing as aerial master, and aerial power is the same thing as aerial PTO. All right. And then go ahead and flip the high idle. So we can head to the back of the truck. So we've properly engaged our PTO and set our chocks. The first thing we want to do during our operational check once we get back here is to test the operation of all stabilizer control station indicator lamps by activating our indicator test switch. Unfortunately, like we'll continue to realize, this doesn't have a lot of safety features that we've grown used to, but on your trucks there should be, at the stabilizer control station, a toggle switch that you can flip to make sure that all of your lights are working. And the reason we need those lights to work is because each one of them is going to tell us something important. So if that light is burned out and we're relying on that thing to tell us something and it's not working, that's going to be problematic. So as part of this operational check, make sure all your bulbs are working. Place hydraulic selector valve in stabilizer position. We don't have one on this truck. You won't have one on your buckets, but on all your other straight stick quints, you should have a selector valve that's either going to place that pressurized hydraulic fluid into the stabilizer system or into the aerial system. This can be another source of confusion and another problem that we can run into if we don't know exactly what we're doing and the configuration of our truck. So when we're trying to stabilize this truck, we obviously want it in stabilizer. When we're trying to operate the aerial, we got to flip it over once we're done stabilizing the truck, and so that we can get the hydraulics up there. All right, so Blackstone, if you want to come out here and we'll bring these stabilizers out. Could you two do me a favor and grab those stabilizer pads and put them out? Yeah, we'll do this side real quick, and then we'll go over and do the other side.
Are y'all gonna have us, like, as far as the handle configuration? situation? We were talking about that at the station. Like, do y'all want handles inside, outside?
Typically, we want the handles inside. I'm not gonna get too crazy on this one.
Sure.
So go ahead and.
I wanted to ask that while I was thinking.
Yeah, no, it's all good. Yeah, a lot of people say it's the way they're welded on. The handles are these days. They're up and out from the plate, as opposed to these that are bolted on the top. So they say it's a trip hazard if they're out. So just take that extra millisecond and point them inwards.
Good to go ahead.
Yeah. All right, Blackstone, go ahead. Yeah, you're good, man. Perfect. Did you go all the way out on that one? What?
It reached
Yeah.
all the way out.
All right, cool. Yeah, we'll get to that. We can touch on it right now. That's another source for debate is, when are we stabilized? How far off the ground? Or do we want the tires on the ground? Do we want the tires off the ground? First and foremost, we're definitely not stabilized until we have our indicating lights telling us we're stabilized. Over here, this is burned out. This one's definitely out. So we have all our lights telling us we are stabilized. Then, how far up off the ground do we want is the debate. We've been teaching for a long time now that you want those tires up off the ground. Now we've been told by Pierce just today that you don't want the tires all the way off the ground, that you want the pressure removed from the tires. So they say take the bulge out of the tires, but we still want the tires on the ground to provide that extra level of friction with the ground. But seeing as how I've read a Pierce manual that in the same manual, in one place it said leave the tires on the ground, and in another place in the same manual it said take the tires off the ground, we don't really see how it's not the end of the world one way or the other. But it's kind of the same thing with the drain. If you choose to do it one way or the other, you might get asked, why are you doing it this way? And we're going to want you to say, we've researched it, we trained on it, my captain told me to do it this way. We heard for this particular truck, it's better to do it this way versus the other way. Fair enough? All right. So let's inspect our deployed stabilizers. Stabilizer warning lights. This is very important. We want to definitely make sure these are working. This is what tells the crazy person in the car back there who's pissed about the traffic jam that she can't or he can't drive into this. And that has happened before, and firefighters have died because of that. So they can't see this unless this light is here. If you're in a roadway, we got to make sure that we're lit up properly, all right? Again, we're coming back with the physical damage, fluid leaks, loose or damaged hoses. If you guys want to come over here, we got hydraulics that pushes this beam outward, and then we got these hoses coming in along this beam out through here that will push our jacks down. Same as always, we want to make sure our hoses are good, our connections are good, no leaks. Same story. Check sliding beams for scoring and adequate lubrication. This truck has been around the block a couple times. I think a couple of us noticed when we were bringing the stabilizer out on the other side, it wasn't exactly the smoothest, but that's why this is a 20-year-old reserve. Ensure lock pins present and sufficiently secured. Check for elongation or cracks in stabilizer lock pin holes. That's important. We have these pins that we put in holes on the jacks so that if the stabilizer fails, that's going to catch, prevent us from a catastrophic failure. But us being firefighters, we can be a little forgetful at times, and now we try to bring the stabilizer jack up with the pin still in it. Or if that stabilizer does sag down and loads that pin, we might cause damage to those holes. Is everybody with me on that? So check out those pinholes. Make sure there's no cracks, they're not elongated. They should be circular, not ovals. Stabilizer pads for damage. Nothing rocket science here. Just make sure they're good. The whole purpose of a stabilizer pad is to increase our surface area, to distribute the weight more evenly. I don't know if you guys heard about what happened with Quint 1 in 3's territory. They put a stabilizer out into an asphalt parking lot, which does not have the load bearing that maybe a concrete roadway has, and that stabilizer went into that parking lot. Another thing that didn't help our cause very much is that we've gone to these composite plastic stabilizers, and in the picture, the stabilizer is pushed down in the middle and flayed out at the ends. So obviously that wasn't distributing the weight to the whole footprint. So I got a feeling we're going to be going back to the metal stabilizer pads. Reserve apparatus for stabilizer sagging. We want to make sure that if we pressurize this fluid in here in this hydraulic system, that we maintain that pressure so that our stabilizers stay where they want to be. If we start to lose that pressure, we can have sagging. I heard for a lot of years that there's fail-safe mechanisms that even if we lose hydraulics, it's going to hold that fluid in there because of a holding valve. Well, if the holding valve fails, then it's not going to hold it in there. And that has happened to us on one of our old reserves where we were training down here, we had our pins in, and after the training was over, we look over and that stabilizer had sunk down onto that pin. So again, as we see here, no pins. This is an older truck before we had that safety feature. All right, let's head up to the turntable and check that out. Why don't you jump on that pedestal there? So we should have, at this point, we would have placed that selector valve into aerial mode because we got to bring the hydraulics up here now. All right. Again, we'd be testing. I don't think we have do we have a testing switch up there? We would be doing the same thing we'd be doing down at the stabilizer control station. That's making sure all our bulbs are good with that testing switch. And then we'd be operating controls to fully elevate and extend the aerial for the sake of time. I know we're not rotating already. All right, Kessler, go ahead and raise this aerial up for me. All right, that's good. All right, now go ahead and push that down. Other direction. All right, that's good. Returns to neutral. So, in a real operational check, you would be raising this thing all the way up and lowering it all the way down, full range of motion. You'd be extending it all the way out and all the way back, and you'd be doing a 360 in one direction and then a 360 back around in the other direction. Checking the full range of motion, making sure all the operating systems are working properly. Once we have it extended, let's go ahead and move it out to the side and extend it a little bit. That's good. Go ahead and move it out a little bit further. That's good right there. And then why don't you move it down a little bit? That's perfect. That's good. All right. What I would recommend for you guys is, if you have the space where you're doing this, is to fully extend this thing, put it out to the side, and then lower it as well as you can, so that you can walk this thing on the top and then get a visual on it from the bottom. And what we're going to be doing is the same thing that we've already done. We're going to be inspecting the extended aerial sections instead of the retracted sections. Doing the same thing we've already done. Check for excessive wear, cracks, loose or missing parts, improper alignment, checking beams, rails, alignment systems, truss work, all that good stuff. Making sure our rungs are good. Yep.
This thing prevents you from going down too far if you're kind of like at this angle right here?
Yeah, the new trucks will. I'm not positive about this one, so yeah. I mean, you're good, but yeah, we're good. The newer trucks do have a collision avoidance, so they will disable your controls if it thinks that it's going to hit itself.
Okay.
But those things fail, so always don't just be reckless about it. All right. Again, same thing we were checking before with the extension retraction system. Checking the cables, checking the guides, checking the hydraulics. Checking the waterway now. Now the waterway is extended. It's a telescoping waterway, so each section slides out from the section before it. Now we can put a visual on that, and we, just like before, we're checking for damage to piping, connections, and seals. Communication system is very important. You want to check that. One person down here, one person up there. When somebody's up there operating in an IDLH with the air pack on, face piece on, trying to direct 1,000 GPMs, they shouldn't have to mic up on this to talk to you. They should just have to talk into that speaker and let you know what's going on down here. So make sure the communication system works. Aerial monitor remote controls, you want to check and make sure those you can direct that monitor from all locations. The tip controls, the pedestal controls, and if we have controls on the pump panel as well, which I think you all do have monitor controls, your nozzle controls, you want to make sure those work. Testing operation of aerial lighting systems, you want to make sure lighting up the scene as an aerial driver, take pride in your job. That's a very important aspect of it. It's something that I think is kind of fallen by the wayside. Get those halogens going, get your tracking lighting going, make sure it works beforehand so that on scene you can fire it up real quick. That's a safety issue. You could save somebody's life by lighting up the scene properly. All right. I think that about does it. So as we're doing all this, just like with the stabilizers and the sagging the stabilizers, the way they word it here is checking the aerial device for dramatic drift. And basically what we're doing is making sure that this thing stays where we leave it and that that hydraulic pressure is being maintained. Just like we're checking the monitor controls at every location, at this point you'd want to go to the tip and make sure the tip controls work. If it's a bucket, make sure the bucket controls work. If you have aerial controls at your pump panel, make sure you can move this aerial with those controls. And that, besides the EPU, is pretty much it. We can't check the EPU with this one because it doesn't work. And that's okay because we're gonna get a lot more training as far as the EPU is concerned further on in this course. So that is our weekly visual inspection and operational check. Each truck is different. I try to give you as much of what we want you to know as we can, but each truck is different. So there's gonna be different features, different intricacies, which each one, you guys need to come down here and be the one teaching us about what's going on with your truck. Does that make sense? So, all right, any questions on anything? All right, thanks for your time. Kessler, if you want to bring this thing up, retract it.